So, in the previous class we have learnt the two steps required in the process of measuring temperature. The first step was to select a thermometric property, and the second stage was the assigning to a numerical value to a standard reference point that was selected as triple point of water, and the numerical value assigned was 273.16 Kelvin. Now, let us see a constant volume gas thermometer. This is not a normal thermometer, clinical thermometer or day to day life we will be using it. These are standard thermometers, they are very accurate and precise, and they are used in laboratories. They are very costly and bulky apparatus. So, now in this thermometer, this is your thermometric bulb. This portion is thermometric bulb, thermometric bulb, which is made up of platinum or some alloy of platinum or its alloy. In this thermometric bulb, a gas, any gas is taken, and this gas you see fills this region. Now, here this is a glass tube, this is glass tube which is open here, and in this glass tube there is a round marking. We call this point as indicial point, indicial point, and in this tube we can fill mercury through the help of this reservoir. So, this mercury is up to this stage. So, this is the mercury, we can see the mercury through the glass tube. So, this shaded portion is the mercury. So, this is the reservoir, so that the level of mercury can be changed in this U tube. So, this is the reservoir and this is the mercury here also. So, this is a tube through which, so this is the schematic diagram of a constant volume gas thermometer. Now, let us see how we are going to work with this thermometer. So, this is the schematic. Some scales will be also provided, so that we can measure that how much height this difference is from this initial point. This is measured with a help of a scale provided here. So, now how to do this, take the measurement. So, now the basic process here is, the thermometric property here is that at constant volume the pressure of an ideal gas varies linearly with temperature. This is the thermometric property we are going to use. So, pressure is proportional to theta at constant volume. So, when volume is kept constant, V is kept constant. So, pressure is directly proportional to the temperature. This is the thermometric property we are going to use. So, when we put this thermometric bulb in a bath whose temperature has to be measured, then what happens? The volume of this gas changes, and so this layer of mercury may come down or sometimes may go up. So, what we have to do? We have to always make this mercury level coincide with this initial point, so that the gas occupied in this bulb has only this volume. So, that we should always keep the volume to be constant. So, in order to make this volume constant, this mercury should always coincide with this initial point, which can be adjusted by making up and down movements of these reservoir. So, in this way volume is kept constant. Now, let us see how to proceed with this apparatus. Now, first we put the bulb, the thermometric bulb in the bath whose temperature has to be measured, whose temperature has to be measured. So now you just see we have put this into a bath. This is the bath. Suppose some liquid, molten liquid is there and whose temperature has to be measured. Suppose this bath is hot. So what will happen? This gas will expand and so the level of mercury goes down. Now what we do? We increase the level of reservoir so that again the mercury comes to the same level. In that case, the volume of this gas is confined within this and it is made fixed. So now in order to do so, we observe that this is the height h. Height, that is, this is the difference between this level and this, which we can measure from the scale provided here. Now this height of mercury plus atmospheric pressure, this is open to atmospheric pressure, is the measure of the pressure of the gas in this liquid. So the excess pressure over the initial point is measured, that is the pressure of the gas. So this height h, so the pressure of the gas when the temperature is theta, suppose its temperature is theta, that has to be determined, its numerical value has to be determined. So pressure at theta will be equal to atmospheric pressure plus h rho g, where rho is the density of the mercury. So this is the way in which first we will determine the pressure of the gas when this bulb, thermometric bulb, is kept in a bath whose temperature has to be measured. So this is equation number 1. We will call this as P theta. Now next we dip this into our triple point cell and do the same thing. So now next we put the bulb in the triple point cell and again measure the pressure of the gas by old method, that is by changing this reservoir we see what is the excess pressure, and so suppose this time pressure at triple point is equal to Pa plus H, that is H3 rho mg. So this is equation number 2. So what we have done, first we put this thermometric bulb in the bath whose temperature has to be determined and see what is the pressure of the gas. We got P theta as this much. Next again we dip this bulb into a triple point cell and again calculate what is the pressure of the gas at triple point. So once I determined P at theta and P at triple point, then we will use the principle of thermometry to calculate the numerical value of theta. Now according to the principle of thermometry, the temperature theta will be equal to that temperature at triple point by P into P at triple. So since we can say pressure is proportional to theta, we can write P is equal to K theta. So we have P by theta is equal to K. So theta by P is equal to theta triple by P triple. So you see, now we will put this P value here and P triple value here. So this is theta and theta triple is the numerical value as sine to triple point is 273.16 by P, which has to be measured, and P triple. So this is the, so what we have to determine by experiment, I have to determine the ratio of P by P triple, and automatically that this by this into 273.16 Kelvin is the temperature assigned. So what we have to calculate is simply P is Pa plus H rho mercury G by Pa plus height at triple point rho mercury G, this much Kelvin. So this is the numerical value of theta. Thus we are able to measure the value of theta and assign a value to it. This is what we do in the measurement of temperature.